Be it machined, cast, moulded, sheet metal, Solid Edge with synchronous technology allows you to create your parts as fast as you can think. We've just been briefed on a new spring clip that's needed, so let's throw this concept down. Starting from a blank space, we'll sketch a rectangle roughly the size we want and pull that into a sheet metal gauge. For a couple of flanges at either end, we can simply pull these out too. Let's do the same thing again to add a couple more flanges. And all the time, watch how we're working with our geometry rather than clicking through commands. Design is the focus here, not the software. Oh, and the design here should be for these flanges to angle out. No need for delete or undo. We can use what we call the steering wheel, our main control in synchronous technology, to angle. But not both sides, I don't think. No problem, we'll just tell these faces to be at right angles. Just because we created these symmetrically doesn't mean there's history-based design intent tying us down, like you get in most any other CAD system. Easy. Okay, next up we need a guide for the USB block that this spring clip will hold. A bead would be ideal, and that's as easy as sketching a line where we want it to be, and then choose the size and shape of our bead. This one I used in a previous project should work just fine. Next, let's create a cutout to go through all three sections of the sheet metal on the right hand side. Oh, and check out this method as an even quicker way of sketching shapes. Nice. We'll centre that up, and although this is a concept, I do know this needs to be 16mm in width, so we'll tie that down. Another simple drag, this time to remove material, but we want this cut to be created before the part is bent into shape. No problem, Solid Edge can flatten the part on the fly before cutting. Very nice. For the retaining clip that we need, let's drag out a couple of flanges here and angle them both in. Same process as before, pull to create, and then the steering wheel to angle. We also need a sidewall to contain the connector block, so let's add another flange. But the material needs to be on the inside, and a partial flange, not a full. Great! Along with the USB block, this spring clip needs to clamp a fuse holder. We'll pull out another partial flange, and then let's mirror this across to the other side. Oh no, we've made a big mistake. The design brief clearly stated that this top sheet metal piece needs to be angled. I completely forgot. Remember that this was the first piece of geometry that we created. Everything else is built on this. But also remember we're using Solid Edge with synchronous technology. Check this out. Steering wheel to the rescue, simple rotate, no drama. Let's get back to working on the clamp for the fuse holder. Remember we mirrored this, and notice along with everything else, this has been added to a feature tree. Yes, it's direct modelling, but there are still features to work with, like in history-based CAD. The best of both worlds with synchronous technology. That means we can edit the feature, breaking the link so that we can work independently on one side. And now we can add the jog that we want on this flange. Same process as the bead here, just a simple sketch line, and then apply the jog. Let's do the same for our retaining clip. Again, same process, simple sketch line where we want this jog to be, and then apply that jog, dragging it out into position. Easy. Finishing up on our concept, let's get rid of some sharp edges by breaking corners. Nice and quick, click and go. And finally, we were briefed to include a hook to mount the whole spring clip. For this, let's push in the width of that second flange we created. And let me just repeat that, the second flange we created. No need to worry about the order that this was modelled, we're free to make this change. And then let's use a hem to create the hook. Choose the right size, and done. So in a short amount of time, we were able to throw down this pretty complex design, working directly with the geometry rather than in and out of multiple CAD commands. And that's how it should be, no? Design the focus, not the software. And you'll be happy to know that even if you don't create sheet metal components like we had here, you'll still enjoy the same rapid workflow. Minimal sketching, minimal mouse travel, easy push and pull modelling, and importantly, no need to worry about what order should I do this in. The flexibility to change your mind at any time. That's synchronous technology in Solid Edge. Designed better.